Right. In example 7 and 8, we have a couple application problems. Example 7 says, suppose that f of x equals 100x squared minus 5x, 1,000 units are sold, where x is the number of years after 2,000. So what is f of 10? And the answer to part A gives the number of thousands of units produced for what year? Okay, so this is just understanding function notation, right? If I have my function of f of x, and now they want to find f of 10, this is just simply telling me that x equals 10. So if I have f of 10 equals, and now in place of both of these x's, we're going to replace it with 10. Not as important here, but we are going to substitute with parentheses. So I have 100 times 10 squared minus 5 times 10. Okay, so definitely not doing this one by hand. Let's put it in our calculator. And I will put it in just the way I see it. And so we get 9,950. Okay. Now, this is going to happen a lot. The answer to part A gives us the number of thousands units produced for what year? And it tells me up here what x equals. X equals the number of years after 2,000. The key word there is after 2,000. So if my x is 10, I'm not going to say in 10 years. And yes, that's true, but it wants to know what year we are in. So we are doing 2,000, what it is after, plus what my x equals 10. So this is for 2010. So really, it's in your Desmos homework, but we really don't need Desmos for it. However, we can use Desmos. Not for part B, but we can use it for part A if we wanted to. What do I want? I want this over here. Okay. I'm going to exit this out from last video, and I'm going to type this in the way I see it. And hopefully you are doing this with me and following along. Okay, here's my function. Now, really and truly, it does not matter if I can even see this in here. One thing I haven't really shown you here is if we hit this little home key, it says default viewport. This will make me go back to really kind of like the original numbers here. So click that home. It does not matter if I can't see what I need, okay? In the second line, if they want to find f of 10, if I type in f of 10, got crazy on the parentheses there, it will give me that answer right there. So I told you last video or a video before, I don't know, a video in this lesson, that Desmos is actually really good with function notation. This is what I mean. If you type this in with function notation and you want to then find a value for x, you can type that in and it will give that to you. So that's kind of a cool feature. But again, we have to be able to do this by hand. Okay, let's do one more example for an application. And this one's a little tricky, but that's okay. All right. Example 8, if a ball is thrown into the air at 64 feet per second from the top of a 100-foot building, its height can be modeled by the function s equals, where s is in feet and t is in seconds. So I didn't do this last time, but typically I do like to go through and underline what all my variables mean, because we're probably going to need those in the future. Okay, so S is in feet and T is in seconds. So first thing I want to do is graph this function for T representing 0 to 6 seconds and S representing 0 to 200 feet. Okay, so I can go about this a couple different ways. And let's go ahead and do it this way. Let's go ahead and type this in here. So exiting out of everything. I've got S equals 100 plus 64T minus 16T squared. Okay, so there's my function, which this function is pretty cool, actually. Let's do the and I want to talk about this function. So where T is representing 0 to 6. So when I look at this equation here, usually my independent is in the variable of X. So when they're talking about T, I could really rewrite this problem as Y equals 100 plus 64X minus 16X squared, right? I can change the variable to anything I want. When we have equations, we're typically seeing X as part of the equation and it's not T. So when they say that T is representing 0 to 6 seconds, here they're talking about the X min and the X max. So when I change my viewing window, I will go from 0 to 6. Doesn't tell me the scale or the step, but 1 would be a good one because it's not a very big x-axis. Okay, and S representing from 0 to 200. Well, again, usually our equations are Y equals or f of X equals. And so instead of S, I could have rewrote that as Y. So when they say S is representing 0 to 200, this is my Y min and my Y max. So I will change this from 0 to 200. And they went ahead and did a scale of 50 here. If I want to make that a little bit smaller, I think 20 would be a little bit more appropriate for mine, but you can see now the trajectory. So here's what I wanted to kind of talk about. This type of equation is something we're going to see often, and it's a pretty cool equation. They use that 64 and that 100 in this equation. It says the ball was thrown at 64 feet per second. Whatever's with my X coordinate or my T coordinate, or not coordinate, but my X or my T variable, that is representing my velocity. So that will always show how fast something is going from the start. And then the 100-foot building will be the one without any variable. And so you can see here, I have a Y axis of 100 because that's where it's starting. So it's starting on this 100-foot building. It's going to go up and it's going to go back down. Now, this negative 16 at X or T squared represents why it goes back down. Why, when I throw this ball in the air, is it eventually going to come back down? Why won't, when I throw it up, it just keep going up forever? And that's our gravity, right? So with these here, you'll always see a negative 16 with that squared variable, and that's representing our gravity. Okay, so here's kind of the trajectory of this ball that we threw. So part A, graph the equation on this window, check, here it is. Part B, find the height of the ball after 1 second. Find the height of the ball 1 second after it's thrown and 3 seconds after it is thrown. Okay, so for 1 second and for 3 seconds. Now, when we are talking about time, are we using, is that representing by the x-axis or the y-axis? So we already kind of talked about this right here, how 100 here is my 100-foot building that we're starting on. My y is representing my feet, okay, how tall this is, or what the height is. My t is my seconds, which is down here along my x-axis. Okay, rewind that if you want that explained again. But when we are talking about seconds here, we're talking about this x-axis, and that's what's measuring my time. So to be able to find this, I'm going to go into my second line and I'm going to type in x equals 1. And then for this one here, we'll type in when x equals 3. We want to then find the intersection. Okay, so second line, we've got x equals 1 because my x-axis is what's representing this time. And where is this crossing? It's crossing at 148. Okay, now word problems need word answers. It says find the height of the ball. So my answer is not 148, it's 148 feet. I'm in units of feet here. Okay, let's try at 3 seconds. So now I'm going to just change this to a 3. And where is it intersecting? At again, 148 feet. Okay, I'm a little out of room here, but it says, how can these values be equal? So if I actually put n here, okay, why are these two values here equal? Well, this first one is representing when the ball is rising, and then the second one is representing now when that ball is falling. So I'm going to put ball rising. This one here is when the ball is now falling down because pesky gravity came into play. Part C wants us to find the maximum height of the ball. So you can leave these in here if you want, or you can get rid of them. But remember, if you click on this graph here, it will show you two things. It shows you your axis. So here's my x-axis. Here's my y-axis. And those two things are representing important things that we will get into in future lessons. This is how long it takes for the ball to hit the ground, so roughly 5.2 seconds. And this one represents the height of the ball when it started at 100 feet. Important things. Okay, but this wants to know the maximum height. And so when I click on it, that's right here. So the maximum height is 164 feet. Now it doesn't ask here, but sometimes it will ask like, when did it reach the maximum height? And then that has to do with our x coordinate because that has to do with the time, right? So that would be 2 seconds. Okay, one more video. We're going to go over a scatter plot.